Welcome students, this is March 2021 question paper AS Pure Math 1. So this is the first question. Let me write the question down. The question is, find the first three terms in the expansion in ascending powers of x of 1 positive x raised to the power of 5. So this is question 1, and the next question is find the first three terms, same pattern, in the expansion in ascending powers of x, and we are given 1 negative 2x raised to the power of 6. And there is a third part. The third part of the question says find the coefficient of x raised to the power of 2 in the expansion of 1 positive x raised to the power of 5 multiplied with 1 negative 2x raised to the power of 6. Okay. Now let me handle part A. Part A wants us to find the first solution. Solution for part A is what? Find the first three terms. Of 1 positive x raised to the power of 5. Now we know the binomial expansion. What is the binomial expansion? Of a positive b raised to the power of n, sigma k is equal to 0 to n nck times a raised to the power of n minus k times b raised to the power of k. This is the binomial expansion we have. Now if we were to utilize 1 positive x raised to the power of 5, then our a is 1 and our b is x. So this is going to be sigma k is equal to 0 to 5 phi ck times a is 1 raised to the power of n minus k, and my b is x, and that is raised to the power of k. Now, no matter what values that we raise here, right, this is always going to be 1. So this is rewritten as sigma k is equal to 0 to 5 phi ck times x raised to the power of k. So that is going to be our expansion. Now nck, you need to know what is nck. Nck is n factorial divided by n minus k factorial times k factorial. So that is how we calculate nck. Now let me expand this. So therefore this can be rewritten as, so we start with k is equal to 0, phi c0 times x raised to the power of 0 positive phi c1 x raised to the power of 1 positive phi c2 x raised to the power of 2. So the first three terms are obtained here. Now this is going to give me 1. Now phi c0. Now let me show you how to get phi c0. So phi c0, as I mentioned to you, we will be utilizing nck. nck is nothing but n factorial divided by n minus k factorial times k factorial. So 5c0 is going to be 5 factorial over 5 minus 0 factorial times 0 factorial. Now 5 factorial is written there. 5 minus 0 is going to be 5, so 5 factorial. 0 factorial is 1. So you have this to be equal to 1. So I can substitute that 1 there, positive 5c1. Now what is 5c1? 5c1 is 5 factorial divided by 5 minus 1 factorial times 1 factorial. Now 5 minus 1 is 4, you have a 4 factorial, 1 factorial is 1. 5 factorial can be written as 5 times 4 factorial divided by 4 factorial. These two can be cancelled, giving me 5. So you got a 5 there, and x raised to the power of 1 will give me x. Now this is x raised to the power of 2. Apparently because of the overflow, the x raised to the power of 2 went on to the next page, or I would say the adjoining page. So x raised to the power of 2 is present there. So this is going to be 5c2. Now what is 5c2? 5c2 is nothing but 5 factorial divided by 5 minus 2 factorial times 2 factorial. I'm going to write 5 factorial as 5 into 4 into 3 factorial. Now 5 minus 2 is 3 factorial. 2 factorial is going to be 2. So 3 factorial gets cancelled. 2 divides 4 2 times. 5 times 2 is 10. So you take that value of 10 and you place that here. Now as I mentioned to you, this is x raised to the power of 2. So this is what you have got. So these are the first 3 terms. Okay. Now what we have to do is we will have to move to the next term. We will have to expand 1 negative 2x raised to the power of 6. So 1 negative 2x raised to the power of 6. The first 3 terms are required. So from binomial expansion, what do we have? From binomial expansion, we have, what is that? A positive b raised to the power of n is sigma k is equal to 0 to n, and this is going to be nck times a raised to the power of n minus k times b raised to the power of k. So therefore 1 negative 2x raised to the power of 6, I'm going to rewrite this as 1 positive of negative 2x raised to the power of 6. So a is equal to 1 and b is equal to negative 2x. So this can be rewritten as sigma k is 0 to 6 and 6ck times a is 1 raised to the power of n minus k is going to be 6 minus k times b is negative 2x raised to the power of k. Okay, so that's exactly what we've got. Now what we need to do is we need to expand this. Now this, as I mentioned to you, this will be equal to 1, and if I were to run this k from 0 to 1 and 2, so this is going to give me 6c0 multiplied with negative 2x raised to the power of 0 positive 6c1 times negative 2x raised to the power of 1 positive 6c2 times negative 2x raised to the power of 2. So this is what we've got. Now this is going to give me 1. Now 6c0 will give us 1, right? Because you see 5c0 has produced us 1. So definitely 6c0 is also will be giving us 1. So this is 1. Now 6c1, now this 6c1 will give us 6. So 6 into 2, 12. So I have a 12 there, but apparently there is a negative sign. So place the negative sign. X raised to the power of 1 is giving us x. Positive 6c2. Now we will have to calculate the 6c2. So let me calculate 6c2. 6c2 is equal to 6 factorial over 6 minus 2 factorial times 2 factorial. I'm going to write 6 factorial as 6 times 4 into 6 times 5 into 4 factorial divided by 6 minus 2 is going to be 4. 4 factorial times 2 factorial is 2. 4 factorial can be cancelled. 2 divides 6 3 times 5 is 15. So this is going to be 15 and negative 2x raised to the power of 2. That's going to be positive. So it's going to be 4 and an x and a raised to the power of 2. So if you were to rewrite this, this will give me 1 negative 12x positive 16 times x squared. Okay. Now this is part B. So part B solution ends here. Now we are asked to find the coefficient of x squared in this expansion. Okay. So therefore part C is what? 1 positive x raised to the power of 5 multiplied with 1 negative 2x raised to the power of 6. So this is equal to, now 1 positive x raised to the power of 5 is 1 positive 5x, positive 10x raised to the power of 2. Now this 1 negative 2x raised to the power of 6 is 1 negative 12x positive 60x squared. Now we need to catch all the x squared terms. Now, so 1 multiplied with everything will give us 60x squared. So that is required here. So 60x squared is required. Now similarly 5x into 12x, that is also giving me negative 60x squared. So they get neutralized. And you have 10x squared times 1. So positive 10x squared. So these two gets cancelled. So therefore the coefficient of x squared. So if you want to take the coefficient of x squared is, coefficient of x squared is what? Is nothing but 10. So that is part C. So we have got part A, we have answered part A, part B and part C. Thank you. We move on to the next question.